Okay, welcome back, everyone. This is the morning lecture for week 2, day 4. We're going to be going over APIs as it says here. Then in the afternoon, we'll be going over the topics of terminal and Git. I believe everyone here should already have Git installed. So we're going to be talking about terminal, how it relates to Git. Okay, not installing Git and GitHub. We've already done that. More specifically, how we'll be relating terminal and Git together. But for now, we'll be doing APIs. So as you see here, there's no end of the day work or homework. You guys have completed your belt already. So it's a nice, cool couple easy days here until next week. So tomorrow morning, we'll be going over Bootstrap and then media queries in the afternoon. Then next week, we'll be starting our project week. Okay, I'll describe that more on Monday. Let's go ahead and dive into today's lecture topic. And as usual, you guys are free to interrupt me as I'm lecturing if you have any questions so that I can address whatever questions we may have. Okay, ignore what it says here. Okay, who can tell me what an application programming interface is, what it does? Can someone give me an analogy? Okay, I like to think of it this way. Imagine you're the owner of Target, like a Target, local Target store, right? You're selling Target products or other products that is being sold at Target. You have a nice big store where you sell all your products. Imagine that's that could be likened to like an e-commerce store, an API or something. Not an API, an e-commerce store, your own personal store. But now we're thinking about it in terms of real life things. So a big, giant Target store where you sell a bunch of products, furniture, clothes, toys, whatever, you name it. But now you want to sell coffee to customers that are, shopping at your store. What are your options? You can start buying your own brand of coffee. Maybe you have a Target brand coffee, then you'd have to hire employees, teach them how to make the coffee. There's going to be different coffee options, lattes, mochas, this, that. Okay, so you're going to have to create something from scratch, its own coffee organization within Target just to sell coffee to the customers. Or what you can do instead is say, I'll just be in charge of running the Target store, whatever normal Target things do, whatever normal things a Target store would do. I'll leave the coffee responsibility to Starbucks, okay? I'll just employ Starbucks, who has their own, choice of coffee beans. They have their own training program for baristas. They have, their own signature tested ingredients, and it has the brand of Starbucks that people are familiar with that makes them feel more at home with the brand of coffee or their choice of, triple caramel mocha latte Parmigiano or whatever, however you name your drink. I used to be a barista. I should know all these things. So if you want to incorporate some other brand, some other database of ingredients, coffee, training, look, all that, that would be likened to using an API instead of making it yourself, making that whole coffee entity within your store, borrowing someone else's information is basically what an API is to your app. Okay, so borrowing someone else's information related to your app would be likened to using a Starbucks inside a Target if you're running a Target store. Okay, so now with that analogy, let's go into the reading of today's lecture, and then I'll go ahead and show an example of an API as well. An API, an application programming interface, is a concept that will be important for us to understand. At the most basic level, an API is the commands that we can use to make our application, our website, communicate with another application. So that's what I was saying. You have your application, which is Target. Okay, the API we're going to use in this analogy is Starbucks. So our application, which is Target, is going to be in communication with another API, which is Starbucks, right? You're using some other entity to enhance our own. It's already working. It's an attachment to our own. We're not going to build it from scratch. We're going to use someone else's attachment that they can freely give out. Okay, we're mainly going to use this to retrieve information. So that's what it is. It's information. We're borrowing someone else's information. We're borrowing someone else's data. But in the future, we'll be able to use an API to create, update, or delete data. Okay. What that's saying is some APIs are their own applications, right? Like Starbucks can be thought of as its own entity. It's its own thing. It's an application within a greater application, which would be Target. Sometimes it's just data. Sometimes that API can create, update, or delete data. So it's this shifting database. Okay, we can have a stagnant database. We can have a shifting database. More complex ones are shifting. So if they get updated, then that information that you're borrowing will be updated. You can maybe update that foreign database, delete stuff from that foreign database. For an example, let's consider the GitHub API. If we navigate our browser to the following page. So we have a HTTP API, GitHub, users, dev Marissa. Let's take a look at what we're being told to look at here. Okay, so we see here on this, if we go to this URL, what is this? What do we see here? What is this that I'm highlighting? Can anyone tell me in JavaScript what this is? When we start with the curly bracket and we separate by commas and we say on the left side something.
It's an object.
It's an object, right? We're separating the key and value pair by the colon. So this is a giant object. This is just information. In this object, we have the key login, value dev Marissa. We have the ID. We have this ID value. We can see this a bit earlier. I have this Chrome extension called JSON View. If I click it, it takes JSON objects and makes them a bit more readable. It highlights different colors. So that's what I'm using here now. In case you don't see that, you can use JSON View as an extension. Okay, anyways. Here we are. We have login, dev Marissa, ID. This is a number. This node ID is a string. So anything that we use from this API is going to be just information from an object. And we know from our third or our day 2 algorithm, our morning algorithm, how to access things within an object. Okay, we know how to access information in an object. Okay, so if we wanted to use this information, we would somehow attach this API to whatever we're working with and access the information in the API just like we would access information in an object. Okay, so what we've covered so far. APIs are attachments to our application. They contain data. And this API is just a giant object. So if we wanted to access this interface, this programming interface, we're gonna have to access this object here. Okay.
A quick
So
question.
yes.
So for this example, you're saying this object can be an API, but not all APIs are objects.
Not all APIs have to be objects. They just have to be, they don't all have to be in JavaScript. They don't all have to be in the object form. Maybe it could be an array of objects. This one just happens to be an object from the start.
Okay.
Okay. So let's get some feedback on this concept. APIs are just foreign data applied to our application, and in this case, it's in the form of an object. Okay, actually, I don't think I have a poll available that I can use. Okay, let's just type in the chat 1 through 10 if we're understanding this. No more polls here, I guess. The poll option just disappeared on me. So give me a pulse feedback how well we're understanding this concept. Appreciate your guys' participation.
So they use APIs in like with drop shipping websites, right? It's kind of similar to what you were saying.
I think they use APIs mostly everywhere, because you can't create, most companies can't just create data and stuff out of scratch. Mostly, you're going to be working with a lot of APIs from now on. Maybe not immediately in each stack, but as you work in companies, as you work in different areas, dropship websites may use APIs. Generally, the answer will be yes to everything. Almost everything uses an API.
Okay.
If you use, for example, let's say you're building an e-commerce platform. You have your website that you want to build that will display all your products, right? You're going to have to create some sort of like transaction history thing in there. For people to be able to track their orders, for you as the user, as the admin of the website, to see what orders are being created. All right, so you have all that stuff you created, but let's say you don't have a way of processing credit card information, right? You don't have a way of processing credit card information because you don't have the database. You don't have the information to check. Is this credit card a legitimate credit card? Is it fraud? Is it expired? So in that case, you most likely want to use an API that was built for that specific purpose. It has a database that it can access, and you can attach that application on your website to process information. You can still track your history, but that extra task of verifying credit card information, you're borrowing an API. Or for example, when you're logging into a website using Google's login information or Facebook's login information, you're using some third-party service to access a website. That is an example of an API where you're using some other application that's not directly related to the main application. Okay, so those are API services. Okay, so let's go ahead and continue with our lecture through the platform. So here is the object we saw. Okay, and what we see here is that it's a JavaScript object. It's a JavaScript object. Okay. Now let's talk about what JSON is. JSON. JSON stands for JavaScript object. So whatever an object is, this thing, something in this form, notation. Okay. Often the form that we get back in the form, often the form that we get back our data back in is in the form of JSON. So whenever we make an API request for data, the API would usually send it back in the form of JSON, JavaScript object notation. Very similar to how JavaScript is written. Now it's just called something similar. JavaScript object notation. We can access the values inside of it using keys, just like with JavaScript objects. Okay. To access the avatar image, we can write code that will look like data.avatar URL. Okay, so we have to call this API call, this information something, and then we say .avatar URL. That's going to give us this key, which is going to give us this value. And as you can see, this value is also another URL. So it seems like another object, okay? Or it has actually access to an image. Okay, so as you can see, some of the values for these key value pairs are themselves URLs to more information. So it's information nested within information in the form of URLs. Okay, so this could be used to get the SRC of an image, a source of an image tag. Okay, now let's talk about fetch. Okay, so what JSON is, it's just JavaScript objects. JavaScript objects given in this file or this form. Official form is JSON, JSON. Okay, in order to access this object information, this JavaScript object notation information, we need to make a fetch call. Okay, in order to grab that information from another API, we need to fetch that information, right? It's not local to our application. We didn't build this stuff. We need to fetch that information, okay? Just like our Starbucks Target analogy, if you want a Starbucks inside of your Target, then you're going to have to fetch a Starbucks. You can't just make a brand new Starbucks in the middle. You have to call up someone, you know, from Starbucks, say, hey, we need you in our store or something. So you need to make that fetch. You need to make that call. Okay, so let's see what this call entails. How do we access that foreign information that we're asking for? The way we access the data by putting the URL in our browser works to show the data. But if we wanted to bring it into our web page, we'll need to do it using this code below. So this code that it's referring to here. The easiest way we can do this is by using the built-in function fetch. Okay, so here's a keyword, fetch. Fetch has a good support across modern browsers. Okay, so there's different browsers, Firefox, Chrome, Explorer, and the way we fetch information from an API matters so that it can work across all browsers. We can use the function to make what is known as an API call. Okay, so fetch is so that we can call that foreign database where we request the information from the URL we provide. As this API call goes to a separate website, the request must be sent and responded to before we can use the data. Okay, this is key. As this API call goes to a separate website, okay, so it's going to a foreign website, the request must be sent and responded to before we can use the data. So we call, and once we get that data, we must have a response to the data before we use it. Okay. This is usually fairly quick, but we need to write the code to tell JavaScript the results. Okay, so let's look at this block of code. The first thing that we see here that we haven't seen yet is this word async. Let's skip to that. Let's skip this for now and just look at the rest of the function. I'll get back to this in a moment. What we see here is a function. Okay, so this is normal. And then we see the function name with the parentheses. That's normal. And we see the opening and closing bracket. And then at the end here, we see the function call. So everything here is pretty normal so far. Everything we've seen so far looks like a regular function call. Let's go inside here now. Var response. Okay, so we have a variable called response equals await fetch. Okay, so now we have two more new words. All right, a first word was async. Now we also have this word await. Okay, what could that mean? I'll explain that in a second as well. And then we have the word that we were told that we would be expecting to fetch that data. Okay, so we have a fetch, and inside this fetch, we have to put everything in parentheses. And then we have in quotations the URL to get to that API that we were just checking here, this one here. Okay, so we want to access this information. The way we do that is by fetching it and making that fetch related to a variable. Okay, now I'll go ahead and explain those other words. Let's say this information was more than just what we're seeing here. Okay, let's say our API call was like millions of pages long, right? Lots of information here. We're accessing so much information, and not just us, but lots of people are accessing this very link for that million pages information. Like, let's say we're accessing information from the yellow book, right? We want to make a website that you can type in a number on a search bar, and that number will show, what name that comes from. Okay, we're not going to have that information researched out. We know the yellow pages, or somebody like the yellow pages has it. So we'll use we'll use in our imaginary app an imaginary API called the yellow pages. That yellow pages book is so big and so thick, and if everyone's trying to access the yellow pages at once online, well then we don't know when we're going to get a response back. We don't know when we're going to get a response back. So we say in front of our fetch call, await. Okay, what this is doing is saying, I want you to make this fetch call to this API URL, and I want you to continue on with reading the JavaScript code that I have written here. But when you finish this, all right, put this on hold until it's done. Don't hold up the whole entire code just because I've asked you to search this API call. All right, I want you to do this function and then just keep working while you're doing that in the background. Okay, so that's what this await means. It means keep working, keep reading this code while you're fetching this information, because we don't know. This information could come back in an instant. It could come back in 10 seconds. But 10 seconds is too long nowadays for someone to wait on a website for that data to load. So we're going to want the rest of the website to load. But for this API call, we want there to be we want there to be fluidity in our code. So this is going to make the fetch call continue to go while the rest of the code and the rest of our page runs, okay? And this await that is making this fetch call work in the background while the rest of our code is being read. It's not going to stop on this line just for a fetch. It's going to keep reading. Because we have this await that will do this, we have to also have this async keyword next to our function. Okay, this async keyword next to our function says, well, let's think about how a function runs without the keyword async. Okay, whenever we see a function, whenever we invoke the function, that function runs immediately, right? That function is going to run right away. But what does async, what does that mean? It means asynchronous. Asynchronous means not at the same time. Okay, the reason why it's called not at the same time is because I don't want this function to do everything all at once, such as run this fetch call, and to make this function make the rest of the app slow down to wait on this function's call. So inside this function, we have the fetch, but we want the fetch to run in the background while we are awaiting the results. And so because we are awaiting foreign data, this function has to not run all at once. And by that, I mean, it is not going to be the, that person that holds up the line. Let's say you go to like a simple convenience store and you have like 2 items to buy, right? And you're waiting in line, and that person in front of you has like 100 items, right? And they only have, let's say they only have like pennies that they've saved up for, right? They look at you and they say, hey, my order is going to take a while. Why don't you skip ahead of me? I see you only have a couple items. That is what this is doing. Async and await, they work together. What this is doing is saying, look, I know I might take a long time. If anyone else has something more important that's a little bit quicker than me, you go ahead and take care of what you need to do. I have a large order here. I'm going to do what I have to do in the background, but you can go ahead of me while I count my change or while I set up my items to be scanned. Okay, so that's like that person in the grocery store that has a bunch of items. They let you go ahead of them because they have so much to do. So that is what this is in effect doing, async await.
So will you always, if you see an await, should I always expect to have an async?
Yes. Yes.
Okay. Can't have one without the other.
Right. It's very, yeah, you wouldn't see one without the other. Okay, this is not the only way to make an API fetch call, but it's the first way we will learn, right? So there's more than one way to do something always, but this is the first way we'll teach you how to do something using async await for an API call. Okay, so we have this API call on the var response equals await fetch, and we're waiting this fetch call for this API. The next line, we see another variable declared called var coder data. Var coder data. And what this does, it also awaits, and it takes that response. It takes the response. So response was the first API call, right? This is the API call. The fetch. It takes that fetch that's now put in this box, the response variable. And then what we do with this response in this variable is we convert it to JSON. So whatever information in whatever way that we received it from this API call, I want to convert that information to JavaScript object notation. Make it a JavaScript object. That's what it's saying. Okay. I want this variable to be the one that makes the API call. This is the one that fetches it. This is the one that converts that fetched data. Okay. This one here gets that information. This one here packages that information into JSON. So now when we want to parse through the API call, now we just have to parse through a JSON, a JavaScript object. Okay, so whatever format that we receive that information from the call, we're now converting it in the second variable to JavaScript object notation. Okay, and then if we console log this coder data, then we'll be able to see what we're asking for. So let me see here if I've done this already. I have something here. No. So let me go ahead and copy this. Okay. I think I cannot run it this way. So bear with this explanation, and I'll show you a practical example in just a minute here. Okay, so I have something set up. I don't want to get off track here. I'm distracting myself. Okay, let me read this last bit of information, and then I'll show you an API in practice. In the above code, we need to tell JavaScript in the browser to wait for the results to come back and to wait for the results to be converted into JSON format. So that's basically what I explained. This one will fetch the information from the API. This one will convert it to JSON, make it a JavaScript object. So we can go through that object the way we know how to go through an object. We do that by using the await keyword. Anytime we use the await keyword in a function in JavaScript, we need to apply the async keyword to that function. Okay, anytime we use await inside, we need to make the function async. We can still call it like a normal function though. If we're curious why we have to jump through so many hoops just to wait for the data in the API call, it's because JavaScript only runs in a single thread, right? What that means is JavaScript, just like how we've been seeing it run in Trace, it runs this line, then it runs the next line, and then it does the next line, and it does the next line, okay? And then it reads the next line. So it reads from top to bottom. But if we don't put this await here, it's going to read this line, and it's only going to stay here until this is done. We want this to keep working in the background while it goes to the next line, the next line, next line. Okay, so that's the point of writing await. Let's give me some feedback here, 1 through 10, on understanding why we need to make this await. And because we make this await, why we need to make this async. Okay, let's give some feedback, 1 through 10. How confident we feel in saying we understand this concept. All right, thank you guys. If that thread is taken up by waiting for something like an API call, if that line-by-line thread is waiting for something like an API call, it can slow down our website, right? What if the whole website loading was dependent on this to be loaded from the API? Then it's like our website depends on another website's loading speed. That's not good. We want our website to load whether that data from an API loads or not. To get around this, JavaScript uses something called an event loop. This is a fairly advanced concept and something we will learn more about in later courses. Okay, as far as Ajax goes, I'm not going to explain this. We're going to skip that for now. If we have time at the end, then we'll go ahead and get into that. So that being said, I'm going to show you an example of an API and how an API would work in a website that you would have built from scratch. So here I have, and I didn't build this. I used this from someone else, but I can explain how it works. So look at this website here. Okay, it's a game. It's a game that lets you guess who's that Pokemon. So I don't have a database of all the Pokemon that exist. I don't have a database, of their pictures and their names related to their pictures and their abilities and all that stuff. I don't have that written. And if I wanted to look it up, I would be looking it up on some other database that has that information. Now there happens to be an API that has that information available for anyone to use, so they can make apps like this. This is a free API. So there's free APIs and then there's paid ones. Okay, this is a free one, free Pokemon one that lets me get information on Pokemon, on their data, their abilities, and whatever Pokemon information is related to each one. Okay, so based on that information on that database list, I can take that information and make a game out of it. So in this case here, if I click start game, not gonna work. Did I just break something? Oh, I commented it out. Hold on a second. Okay, now it should work. Refresh here. Okay, so who's this Pokemon? And we make a guess. If I click the wrong one, it'll say incorrect. If I click the right one, it'll light up. Okay. If I click the wrong one, who knows this one here?
So,
Yeah.
it looks like Do Trio.
Now we're really programming.
Oh yeah, Keep going.
All right, one more.
Pidgeot.
Pidgeot. Come on now.
Yeah.
I don't even know Pokemon. I know this.
Okay, we're having too much fun here. So one more. Let's see. Okay, what is this? Pikachu. I know this one. There we
Good
go.
job, Sensei.
You better not get that wrong, Sensei.
That is making me uncomfortable. All right. All right. So here's the most basic API call. All right. So let me comment this out. Let me comment out the whole app, the working app. And let's go to this information here. So here I have the function get Pokemon data. I've said var res, that's for result. Most of the time, result won't be fully written out. It'll just be in this 3 letters, res, for result. Okay. So if you ever see res somewhere on a company website that you're working for, res is for result. That is the API fetch. And the one following the res is usually what converts it to JSON. Okay, in this case, we're converting that fetch call we've made to JSON. And then we take that information and we're console logging it in this case. Okay, so let's go to this. Let's go to this link, see what we're fetching. All right, so if we go to this Pokemon API, okay, let's go to the main website. This is what the API looks like. If I go there and I go to pokeapi.co, then I have this API where it kind of tells me here, if you want to get Ditto, then this is what it would look like to get just Ditto. If you want to, go look around through the website, see how you're making different calls to different things, then you go on these tabs here, and it'll tell you, okay, if you want to get this Pokemon's ability, then you put the ID or name here. So there's so many ways to call data from this website that you kind of have to get familiar with the API by just spending time on the website, seeing what it is that they require to make a call for information. So if I wanted Pokemon's specific moves, I would have to say pokeapi.co/API/version2/move, and then the name of the Pokemon or their ID to get that move that I'm looking for. If I wanted Pokemon abilities, or if I wanted, say, Pokemon's specifically just that Pokemon information, then I would have to write it like this: pokeapi.co/API/version2 Pokemon/ID or name.
So what do they mean by ID or name? Like, what are you supposed to put in there?
Each Pokemon has an ID. This one is number 35, and its name is Clefairy. So whatever you put in this area here has to be the ID or name. There's two different identifying factors that would give you Clefairy's base experience level, its height, its order, its weight. So much information related to each individual Pokemon. So in this case, in my API call, I'm making a specific call for all the information related to Ditto. Ditto is another Pokemon name, okay? And I want to get that specific information related to Ditto. When I go into this URL, as you can see here, it's a huge object, right? It starts with all this object information. If I use my JSON view here, we see an object with this information. And it's just nicely organized that I can view here, but it's just so much information related to just Ditto. And in each, you can see here, in the URLs, there's access to more API information. There's API information nested within API information. Okay, so you can go really deep here. It's like a phone book. So we've made that call. We've converted it to JSON. We now want to console log that information. So if we go to our site, if we go to our website here, and I right click, I inspect, and I go to my console here, I see here something that says object. This has to be, because I've only console logged one thing in the JavaScript, it has to be my Poke data. So this is the data I'm getting from here. This now in my console log, I'm able to see the data that I pulled from this website just through writing it like this: var res equals await fetch, and then this API call, then this var Pokemon equals await converted to JSON. So now when we console log Poke data, we are console logging an object, a JavaScript object, right? Because that's what JSON stands for, JavaScript object notation. So let's take a look at that object. Let's open it up. We'll open it up clicking that arrow. And here we see all that information that we see on that URL. Abilities, base experience, forms, stats and types and weight. Okay, it's order. So that is how we now grab that object information, and we can now use this information in our application if we wanted to. We can take this information, post it in the HTML somewhere, or we can access the little shadowy images, which are called sprites. The sprite is what you see here when you're trying to guess the Pokemon's image just by the outline. Okay, so you can get all that information just through this API call. Okay, so now that is the most basic API call that we would have made. So let's go over some terminology here just to reiterate what we're talking about. Okay, so we have an API, stands for Application Programming Interface. We know that it's just a foreign database of information. APIs come in the form, most commonly in the form of accessing data or performing an action. Accessing data would be like accessing the Pokemon API. Actions APIs would be like AI image or generation machine learning. Okay, now those are super applications, which are for generating images and answering questions like ChatGPT or whatever that specific AI tool that you're using. That is an API now that you can incorporate into your application. Some APIs require keys or payment. Okay, not everything is free out there. Some of them are, like the Pokemon one. And JSON stands for JavaScript Object Notation. So we're just converting that API call to a JavaScript object. We saw that it was already an object, right? This is already an object, but we need to make the habit of converting everything we receive into JavaScript Object Notation so that we can then parse through that data. Okay, sometimes it will be an object, sometimes it may not be an object. Whatever the case, we're going to convert it to an object so that we can receive it. Okay, so where were we? Async is short for asynchronous, which means which means don't run this all at once or at the same time. Okay, means don't hold up the whole application for that API call. Whatever function you make to make that API call fetch, make it asynchronous, so it's not it's not trying to hold up the line. Async function, in this case here, async function get Pokemon data, and then we receive here in the parameters Pokemon name. Await executes this code and does not run the next line until it is completed. Okay, so this await here will execute this code, and it will run line by line, but it will not hold up the whole entire application because the function is async. Okay, so this function has specific duties, And for example, this variable, which is going to await this fetch result. So this function is not going to be the function that holds up the line, like the example of a customer with many groceries letting the one with fewer groceries pass on ahead. Okay. And then so we just convert that to JSON, and then we can console log it, we can return it, whatever we need to do with that data, we have it now in the form of JSON. Okay, so I have another example here. We have an async function called display Pokemon data. This variable Pokemon is going to be an await. It's going to get this Pokemon data. It's going to say document query selector PokeSearch.value. And then we say here in this next line, PokeDiv equals document.querySelector of that Pokemon class. Okay, so this is accessing information on our page, on our HTML document. And then we say here another one, another line, PokeDiv, which is this variable, .innerHTML equals empty quotes. This div.innerHTML, add to it an H1 of the Pokemon.name. So this variables, this function calls .name. And then we're also adding to it the sprites. Okay, this is not necessary actually. I think this was an extra part of the API. The actual API, the way this whole app works is through this code here. So let's uncomment all of this. Now I'm not going to try to explain this whole application, how it works. That's not the point of this lecture. We can skim through it really quick just to get a feel for it. But the point of this lecture is to show you how we could make an application based on an API fetch. So we have empty variables here. One's going to be for the game answer. One's going to be for accessing on our let's see here. So we have some context. Query selector game screen. So there's something on our HTML called game screen. Okay. And that is this here, game screen. I'm not sure exactly what div it is, but we can find out. We inspect. There it is. This empty div here below, this is our game screen. So we're accessing it, creating a variable out of it, and then the status here as well. The game status wraps the whole screen, and we're accessing that by this ID. Now, then we have a function, async function. We're going to make the result fetch Pokemon. And this is how you make a specific API call for the first 151 Pokemon. Okay, I got this from reading the documentation on the website. I can change this number, make them a higher number of more Pokemon, but I just want to stick to the 151 Pokemon. So that's what I'm using, all the data of 151 to play the game. Then I'm taking that information here and putting it in a variable and converting it to JSON. Now I'm just, at this point, I'm just changing the inner HTML to be empty quotes for game window and game status. And then we have a function called getAnswers. GetAnswers is defined below, but we can call that function within this main function, and it's going to get PokeData.results. So this PokeData if we say dot results, we're accessing that object and we're calling this function now with this API call information in it. We console log it, then we return it. Okay, so then we give that data to this here, and we also console log it. Now that we have done this, we're calling this function. So now let's look at what this function does. It has the answer in a string, and it has options in an array. It iterates through 5 here, and it does it makes a variable called rand. Then we use ceiling, and we use math.random times the array length. And then we as we iterate in this for loop, we push to this array, pokeoptions.push our array at rand. So some random number in our array we want that we would have received here and get answers. And remember, we're passing this information into R. So R is pokedata.results. R receives this information, and then we say pokeoptions.push that information at a random number. So that's how we're getting random whenever we're playing this game. That's how we're able to get, let's refresh it. That's how we're able to get 5 random Pokemon names out of all the 151 that I'm calling from. And then it says the answer is going to actually be out of these options in the array, math.floor, math.random times 5. One of these random answers is going to be one of the 5 here. And then we have this variable says answer res, and we're going to await a fetch call for the answer name, and we convert that to JSON. So then we say let this variable game answer equals answer res.name. So there's a lot of work that went into this whole API, this whole application. And so it's going to take some time, not only to understand, but you have to kind of know the geography of the whole entire function, and you have to read it a couple times to make sense of it. It's like reading a novel with lots of different character names in the book. You have to kind of go back and reread it in order to get familiar with the different characters and their names. So in this case, we have variables. We have to read through, understand what our variables are in order to see how they're connected with each other. Okay. So this is not something we're all going to understand right away in this lecture, but we can read JavaScript now. We know what a for loop is. We can see here for let Pokemon. Okay, what is Pokemon referring to? If you do Control F of Pokemon on this page, we'll see here how many times it's being used at different stages. So we'll know the first iteration if we search, for example, the first instance of Pokemon. Where did we call it? The Pokemon of Pokeoptions. Okay, so in this instance here, this is a new way to write a for loop that we haven't introduced yet. Usually we would have written for I equals 0, I is less than Pokemon options at length increase I. This is a new way to write a for loop. Okay, we haven't introduced this yet, but I'm trying to make the point here that this is JavaScript and we can't read it. So what we know here is let Pokemon. So this is the I, this is the index of the array Pokeoptions. So when you see something written like this, for let Pokemon of Pokeoptions, this is a for loop. It's going to increase by 1 through each option in PokeOptions. PokeOptions is the name of the array, and Pokemon is the name of the index. Okay, so this is just another way a for loop is written. Instead of saying let Pokemon equal 0 while Pokemon is less than PokeOptions dot length Pokemon plus plus. This is a new way to write a for loop that we're introducing now, but essentially is the same thing that a for loop does. Okay, Pokemon is now just the index, and PokeOptions is the array length that we're going through. Okay, then we say PokeWindow.innerHTML, GameWindow.innerHTML, so we know what this does, and we know this is just a variable. We defined, where did we first define it? Game window equals document query selector, this ID. So this grabs that game window. So then we say game window.innerHTML plus equals this image here. Okay. And so we grab this image information and then we give it a class. When you see a money sign, you are just what's called a string interpolation. You're taking a string and then you're adding it to whatever specific part of the JavaScript that you're wanting to add it to. So we're just adding a string here. This one iterates through the array of PokeOptions. So let Pokemon a PokeOptions, then we say add to the game window this button, which on click on this, then we can create an on click in JavaScript saying the answer check this, and then the Pokemon name. That's how we're able to check the answer of whatever button that we click that has the correct Pokemon name. Okay, so the point of this is not to explain how this application works, but that we can work this application using the data that we would have received from this Pokemon API. So what I'll do is I'll link this in our GitHub. You will be able to access this by going to calendar, going to GitHub, and then seeing from my lecture notes for today, this API for Pokemon will be in there, and you can dissect this for yourself, tear it, try to understand it bit by bit. But what I want you to take away from this lecture is that I'm able to build this application now. All right, this is just CSS. This is just a background image, HTML, CSS, and I'm using API calls in my JavaScript now to pull this information that I can use it on my app here. Okay, so this is our introduction to APIs. The best way to get acquainted with an API is to try and pull some data. Okay, obviously you guys are not at the level where you would create this complex of a app yet, but we can start increasing our skill to get here by first understanding how something like this is written. Okay, so I'll have that code for you guys to read there. And for Ajax, okay, I do want to talk about this, but it's not going to sink in until maybe your other stacks like Python or React. So I'll introduce this concept, but I won't expect you guys to understand it right away until you guys put into application a little bit later. Okay, so what Ajax is, well, I'll go ahead and read it and explain it. When working with traditional servers, so the servers are the computers that hold information, like API information. When working with traditional servers, each interaction the user has with the website, like navigating to a new page or submitting a form, will result in a new page being sent and the web page refreshing. So any interaction with that server, for example, let's say you're on Facebook, right? And you like someone's post. You liking that person's post is going to change the likes on that post, that it's going to increase by 1. And let's say the person that posted it sees that like increase. Instead of them having to refresh their page to see the like increase, it's going to show up automatically. All right. The way something like that is done is through AJAX, asynchronous JavaScript and XML. We won't explain what XML is. Don't even worry about it now. It gives us the ability to update data or submit data on a web page without needing to refresh the page. So if I had API information, for example, let's say I pulled some API data on a website that I'm building that's supposed to track when flights are supposed to be leaving and arriving. Okay, so in order for this website to work without someone needing to hit the refresh button every single time, we would have AJAX, which refreshes that API data on my web page without having the user on my web page to refresh the web page that I built. Okay, we haven't worked with traditional backend server, but when we do, we'll be able to apply AJAX to allow us much of the document object model manipulation we have already learned for a smoother experience. So that's what we're aiming for, a smoother experience. So when there's an update to the API, we want to see like an instant update on our web page that's hosting that API call, that API data. So instead of having to refresh, then they would just update automatically. So this is what this is. You guys won't, like I said, apply this until you make a back-end server. But once you do, you'll know what we're talking about here, AJAX. But this is much related to APIs because it's foreign data information that we're incorporating.
We have already said this, but are we gonna eventually make our own APIs and stuff like that, or?
You may not make maybe in the future you will make an API, but you'll definitely be using other people's APIs. You'll be making applications using other people's APIs. Yeah, you may well make your own API somewhere in the future, but it would look something like this. You know, it would probably look something like this Pokemon website, where you have this documentation, how to access the information in order to pull it onto your page.
Okay, but in the course of our program, will we go back to using APIs at some point?
Yeah, you would. It's definitely in your later, I think later assignments in React, in the React stack, you would be using APIs as part of assignments and stuff. You wouldn't be required to build an API, but sometimes things are flexible. Maybe you're building an application and then it becomes an API, or it's like whatever you build may be useful to someone else, so they may incorporate your code into their code to make something better. It's like the analogy I'm saying of using Starbucks within a Target to make Target better.
Okay.
So that was a good question. Any other questions about APIs, about how we would use them, about
this question might be reaching a little bit, but I saw in your JavaScript code you were using some of the functions that we've learned how to reference in HTML, like the ones in green. Why would you use them here and not in HTML, for example?
Because on the main HTML page, we don't, so when the page initially loads, we just have this empty area here that we're accessing.
Okay.
And when we start the game, we don't have the buttons defined, for example, that would click the answer for which Pokemon it is. So then we incorporate into our JavaScript, add this button along in there when we get to this step. And this creates different buttons that you can choose from that will be the game.
Okay, got it.
Okay, and I think this lecture's gone on long enough, so I'll go ahead and end it now. If we have no further questions, I guess we should play this game like maybe a couple more rounds and then go ahead and go off to lunch. So, any questions? What if I make this game a little harder? I'll increase the number here. So make it 400. What's this one?
Spinnerack.
Oh, Matthew said that right away.
I'm a Pokemon master, man.
Oh, okay. We're dealing with that. Okay, what's this one?
Rhyhorn.
Oh my gosh.
The first one.
I just saw a viper and it looked like a snake. Okay. All right. Well, I'll link this for you guys to use on your own. Again, it'll be in the GitHub section here. And let's go ahead and look at our calendar one more time. So this afternoon, we'll be going over terminal and Git. This is another good lecture. It's a good introductory lecture to terminal. I like this lecture a lot. Hope you guys don't miss it. Don't miss it for the sake of attendance as well. But this will be a fantastic lecture on how to use terminal, what it is. Has anyone used terminal before? Nope. Okay, cool. Then that would be
A
good.
little bit.
A little
No.
bit. All right. Awesome. Okay, well then let's go ahead and end the lecture. I'll stop the recording.